semester. Paper name is mechanics. Okay, దీంట్లో మీకు 4 blocks ఉంటాయి. ప్రతి దాంట్లో 2-3 units ఉంటాయి. So
Madam,
first
isn't it English medium class or is it Telugu medium?
this is English medium class.
Then, ma'am, why are you talking in Telugu?
Okay, you can explain in only Telugu, English. Okay.
Yes,
So
ma'am. Because
other members is also more members is in Telugu medium is there, no? So I will talk to Telugu. So both.
no, ma'am, but
Telugu.
we don't know Telugu because we only know English or any other language.
Okay.
Like Hindi.
Okay.
You say
No.
I am also.
Okay,
Excuse
no
me,
problem.
sir,
I
both
can
are
explain.
in
Okay, I can explain both English or Telugu.
Yeah.
Both are mediums. Don't worry.
Okay.
Subject is main, so other words is nothing. Okay, today is physics, that is semester wise syllabus, that is CBS syllabus. So that is a physics semester 1 syllabus is paper name is mechanics. So these are 4 blocks. First block is mechanics of a particle, and second block is mechanics of a rigid body, and third block is central forces, and fourth block is relativity. This is the your syllabus, semester 1 syllabus. So we are discussing only now today is discussing mechanics of particles. So this is introduction of vectors and vector calculus, linear momentum and collisions, and kinetic theory. So these are first blocks units we are discussing. Then these are all subtopics or introduction of vectors, vector calculus. This is your syllabus. Okay. So first now we discussing mechanics of a particle. So introduction of vectors. Basic of vectors and representation of vectors, definition kinds of vectors, some simple properties of vectors, scalar product of 2 vectors, vector product of 2 vectors, scalar and vector field, vector field and scalar field. These are introduction of these vectors. And vector calculus are these are our theorems: divergent, curl, Stokes theorem, Gauss divergence theorem, integrations, line integral, volume integral, surface integrals. So integrals anni kuda these are depending, this is the subtopics. So first of all, now first we discussing in vector introduction. So see, just wait. So first of all, vector analysis. So generally, all the physical quantities are divided into 2 types. Physical quantities are divided into 2 types. First one is scalar physical quantity and vector physical quantity. So vector and scalar physical quantities, these are 2 types of the physical quantities. What is vector and what is the scalar? So don't write. So first of all, what is the vector and scalar? Vector is the physical quantity which have both magnitude and direction are called the vector. These are 2 available, magnitude and direction are called the vector. Don't write shake. Just wait. Okay, don't write, please. physical quantities are two types, that is vector physical quantity and physical quantity, scalar physical quantity. What is the vector physical quantity? Is the which have both a magnitude and direction. Magnitude and direction are called the vector physical quantities. What is the examples of vector quantity? Is the acceleration and velocity and force. These are the vector physical quantity is the examples. With what is the vector? Vector is magnitude and directions. Both are this is physical quantities which are which have both the magnitude and direction are called the vector physical quantities. What is the example? Acceleration, velocity, and force. This is basic concept of intermediates. You know, representation of vector. Vector is the representation of what is a vector, like a that is length of the bar representing the magnitude, and the arrow mark is represent the direction. Okay, length of the bar, the representation of the magnitude, and arrow mark is represent the direction. This is the representation of vector. So as usual, so all are mute lo pettukovali please. Okay, and another one is a scalar quantity. Scalar quantity means the physical quantity which have only magnitude, no direction. That is called the physical quantity. Okay, only only magnitude. Okay, no direction. Okay, that is called the scalar. Okay, scalar is the, what is the examples of scalar? Length and time, mass, speed. These are the scalar physical quantities. So physical quantities are two types: vector physical quantity and scalar quantity. So what is the vector quantity? Is the, that is only both magnitude and direction are called the vector physical quantities. And what is scalar physical quantity? The physical quantity which have only magnitude, no direction, that is called the scalar quantity. So say scalar quantity is represented the, what is the examples? Examples is length, mass, time, speed. These are all the scalar physical quantities. What is the types of vectors? You know, types of vectors is how many types? This is vectors, types of unit vector, null vector, and position vector, that is opposite vector. These are the types of vectors. First one is unit vector. You know, these are basics, intermediate, you can practice that. So what is unit vector? Unit vector is the magnitude is unit. A vector whose magnitude is unit is called as unit vector. That is representation of P. Okay, that is P is the unit vector, then that is mod of equal to 1. That is called the unit vector. A vector whose magnitude is unity is called as unit vector. If P is the unit vector, then that is the that P is equal to 1. And another one is null vector. Second one is null vector. Null vector means a vector magnitude is 0. That is called the null vector. So P is the that of P is equal to 0. That is called the null vector ga representation cheyadam jarugutundi. So, and again equal vector. You know, equal vector, any two vectors are said to be equal, have same magnitude and same direction. So that is called the equal vector. Same direction and same magnitude. That is two equal vector. Like So A and B and vectors, so equal to any two vectors, that is A and B. So that is equal to same magnitude and same direction. These are two vectors. So like det of A vector is equal to det of B vector. That is called the equal vector, two equal vectors. And fourth one, this is the third one, that is equal vector, and fourth one is opposite vector. Any two vector is said to be opposite if they have same magnitude but opposite direction, same. So that is A and B, like let us consider A and B two vectors. These are two opposite vectors, that is called A not is equal to B. This is A vector and B vector is not is equal to. So same magnitude but opposite directions. Any two vectors, that is called the opposite vector. So A det not is equal to B. This is the opposite vector. And fifth one is position vector. You know position vector, like line joining the origin. Let us consider x-axis and y-axis and z-axis. This is, let us consider one point P, that is this is the O, center of O. This is the distance of position vector r bar, r vector, and means then line joining the origin of the coordinator numbers, that is P, and coordination numbers, that is coordinating systems x, y, z. This is the coordinating numbers of P, x, y, z. Then this is the representation of the vector OP is called the position vector. This is the OP line is called the position vector. Like OP is equal what? OP is equal to R. This is the position vector R bar. So what is the position vector R? R is equal to then like x-axis, y-axis, and z-axis. So xi plus yj plus zk. This is representation of I, position vector. Position vector is equal to xi plus yj plus zk. This is the R. Position vector R is equal to xi plus yj plus zk. This is what R det of R is equal to what? Root of x square plus y square plus z square. Okay, that is the det R is equal to root of x square plus y square plus z square. This is the types of vector: position vector and null vector and unit vector and opposite vector and equal vectors. That is position vector R is equal to xi plus yj plus zk. Okay, and type then scalar product, any two dot product, properties of the vector analysis, that is dot product, cross product, any two vectors తీసుకున్నప్పుడు what is the scalar product by two vectors, that is A dot B is equal to AB cos theta, that is then commutative law, distributions law, any two vectors, you can define the any product of two vectors is defined as the product of their magnitude and cosine of the angle of between two vectors. AB is the two vectors, and this commutative law, distributions law are all our properties is dot product and addition, subtractions, any two vectors తీసుకున్నప్పుడు additions, subtractions, scalars, we are discussing in intermediate these topics. Okay, so next, what is the scalar field and a vector field? So like a scalar field, then scalar field, whenever a scalar physical quantity is expressed for point to point in the space by means of the continuous scalar function. That is, scalar function is x of phi of x comma y comma z. Then such a field is called the scalar field. Whenever a scalar physical quantity is expressed from point to point in the space by means of continuous scalar function, then field is called the scalar field. Example of temperature distributions in different points in a field, such field is called the scalar field. Temperature distributions in different points in field, that is called the scalar field. That is the scalar field. Again, and vector field. Whenever a vector physical quantities is expressed from point to point in space by means of continuous vector function, that is phi dash of x comma y comma z, then field is called the vector field. Vector distributions is different at different points is field. Such a field is called the vector field. Okay, that is the vector field and scalar field. Okay, so next, what is the gradient and curl, divergent? These are basics. So first of all, what is the gradient? Gradient is the means gradient. The gradient is a scalar valued function. Is the vector field. Scalar valued function f of x comma y comma z. Then this is gradient of what is the del? Del is the symbol of del operator, that is del. Del is equal to I into dou by dou x plus j into dou by dou y plus k into dou by dou z. This is the del operator. Del is equal to I into dou by dou x plus j into dou by dou y plus k into dou by dou z. This is del operator formula. So what is grad f? Grad f, that is the gradient of a scalar valued function, is f of x comma y comma z in this the vector field. Then grad of f. Grad f means or del f. Grad f means del f. This is del f. Del f means what is dou f by dou x plus dou f by dou y plus dou f by dou z. This is grad f. Then gradient is a scalar valued function, while the output is del dot f is a vector valued function. Gradient is a scalar valued function. Then output of del f is the vector valued function. Okay, so here what del means I dou by dou x plus j dou by dou y plus k dou by dou z. This is the del operator. Then grad f or del f means this is the scalar valued function, that is f of x comma y comma z function. So del of f is equal what? Dou f by dou x into I plus j into dou f by dou y plus k into dou f by dou z. Okay, this is del operator, and del f means that is f, then f means f. This is the grad f. Okay, the grad is a scalar valued function, then output del f is the vector valued function. This is the gradient. Gradient f is equal to the I dou f by dou x plus j dou f by dou y plus k dou f by dou z. This is the gradient. And again another one divergence. Divergence of a vector field, that is f of x comma y comma z is the scalar valued function. Then divergent of f, this is that is the divergent. Div of f is equal to what? Del dot f. This is del dot f is the div f or del dot f is equal what? Del means I into dou by dou x plus j into dou by dou y plus k into dou by dou z. So now f of this is the vector field f of x comma y comma z is the scalar valued function. This is Del dot f means dou f1 dou f x-axis, that is f dou f x by dou x plus dou fy by dou y plus dou f z by dou z. This is the divergent of f or del dot f. This is what is f. F is equal to fx I plus fy z plus fz k. So then del dot f, then multiplication of del and f. What is del? I into dou by dou x plus j into dou by dou y plus k into dou by dou z. And again f, I into fx plus I, j into fy plus k into fz. This is multiplication and simplify. Then dou fx by dou x plus dou fy by dou y plus dou fz by dou z. This is the divergent of this formula, del dot f. Okay, and that is the del. And again curl. Next one is curl. These are all proof that, but simply that is the definitions of a curl and divergent and gradient. So what is curl? Curl is the like a vector function, that is f of x comma y comma z. F of x comma y comma z. That is, what is the curl? Curl means curl f or del cross f, like curl f or del cross f, anything. So that is equal to ijk, det of ijk dou by dou x, dou by dou y, dou by dou z. So that is f. F is a vector, that is fx, fy, fz. X term and x-axis term, y-axis term, and z-axis term. So curl f is equal to ijk det, that is ijk det dou by dou x, dou by dou y, dou by dou z, that is fx, fy, fyz. This is the formula of then cross multiplication. You know, cross multiplication, I term, then this is y and z is cross multiplication. So I term. And again y, j is closed, then x term and z term. This is cross multiplication, that is the j term. And again k term is closed, then x and y is cross multiplication. So simplification of curl f, that is del cross f. Okay, these are all proof that these theorems. Don't worry. So that is the small definitions of gradient, divergent, and curl. This is basic of the vectors. Okay, what is a vector? A physical quantity with both magnitude and direction, that is called the vector. So what is the examples of velocity and directions? Sorry, velocity and accelerations. These are all the vector symbols, examples. So again scalar. Scalar is only magnitude, only the physical quantity with only magnitude, that is called the scalar. Then example of mass and temperature. Okay, so vector is represented a number, that is a number is a number is magnitude, the direction using unit cap or arrow mark, top lo arrow mark అనేది చూపిస్తారు ఈ విధంగా. So and unit, this is the representation of a vector. Okay, a, that is a cap or a arrow mark on this top, or a unit, that is a unit, that is these are our symbols, representation of the vector. And scalar is a number, magnitude, and unit, that is the representation of only scalar. Okay, and that is a vector quantity is defined as the physical quantity as both the direction as well as magnitude. Okay, so that is called the vector quantity. A linear momentum and acceleration, displacement, angular velocity, force, these are examples of the vector quantities. And scalar quantities means is only a scalar quantity is defined as the physical quantity with only magnitude, that is, and no direction. Okay, so that is called the scalar quantity. So some examples of the scalar quantity: mass, speed, distance, time. These are all called the scalar quantities. And what is the vector field and scalar field? Okay, whenever a vector physical quantity is expressed from point to point in the space by means of the continuous vector function, then field is called the vector field. Similarly, same as scalar physical quantity is expressed from point to point in the same by space by means of continuous scalar function, then field is called the scalar field. So again, gradient, divergent, and curl. These are small definitions: del operator, grad f, and del dot f, divergent of f, or curl of f. Curl is the cross product only. Then det, you can find the det. And again, next one, that is curl of a vector field. Curl of a vector field. So like then you can prove that that is the theorem of curl of a vector field. Vector field. Okay, so curl of a vector field, this is the one of the theorem. Prove that maximum line integral of a vector for unit area is called as curl of a vector field. Curl of a vector field is denoted by del dot a or curl a. Can representation of that is symbol of denoted by the curl. Curl of a means del cross a or curl a. Okay, so what is the curl a? That is del cross a means I, j, k, dou by dou x, dou by dou y, dou by dou z, then dou by dou z, and ax, ay, az. This is the curl of this. This is the curl of a vector field. One is the formula. This is the theorem is proved that that is del cross a is equal when proof now. So first of all, let us consider one rectangular. Okay, let us consider one rectangular, that is A, B, C, D. So this is x-axis direction and y-axis direction. This is, so let us consider A, B, C, D vector field. That is the rectangular shape, small rectangular area is A, B, C, D in a vector field. Then choose the sides, that is AB is the distance of dx and CD is the dy, and let us consider one point, let that is P, let us A, B, this is A, that is AB sides, then dx and dy, let P, Q, R, S be the midpoint of the AB side, that is midpoint of this is, these are midpoint. This is P and Q and R and S. These are P, Q, R, S be the midpoints of the sides. Then AB is midpoint of P, and BC is the midpoint of Q, and CD is the midpoint of R, and DA is the midpoint of S. Okay, then let us consider when a vector field, that is let vector field is A, then inside the, then this is the inside the vector field which is resolved the then two directions, then two components, that is AX along the x-axis, AX is x-axis, and AY is the AY along the y direction. Okay, then A vector inside the vectors, that is x-axis direction and y-axis directions. The value of AX is at a point P, AX, that is AX direction, that midpoint of P. Then the value of AX direction, this is AX direction and this is Y, this is, let us consider one point. Then see, this is AX, this is AY direction. Okay, so ax direction and ay direction, the value of ax at a point p, then p అనే పాయింట్ x డైరెక్షన్ లో తీసుకున్నప్పుడు వాల్యూ ఆఫ్ ax at a point p is equal, then see this one. Okay, can p, the p is the, what is the ax minus of dou ax by dou y into dy. So let us ax, that is ax direction minus, so of one of the part of one ax, this is midpoint, so that is minus of dou ax by dou y, that is dou ax by dou y into dy. Okay, so that is midpoint lo తీసుకుంటున్నాం కాబట్టి that is of dou ax by dou y, ax direction into that is dy. So only AB is the vector inside the vector field which is resolved into two components, that is AX along the X direction and AY along the Y direction. The value of AX at a point P, then that is the AX minus of dou AX by dou Y into dy. And again the value of AX at a point R, then upper part, that is upper part, that is the plus value, this is lower part is minus term. Okay, upper part is the plus, so that is R is equal what, a x plus of a dou ax by, see, so upper part is like this is plus, this is R. R is equal to ax plus of dou ax by dou y into dy. This is the value of ax at a point R. So again y direction, ay along the y direction, the value of ay at a point S and Q. S value is the, that is opposite direction, that is negative value. So what is the S? S is equal to, that is y direction, so ay minus of midpoint, that is dou a y by dou x into dx. Okay, so this is the opposite, that is the S is equal to ay minus of dou ay by dou x into dx. Similarly in Q point, the value of ay along the point Q, Q is equal to what, ay plus, that is Q value, ay plus of dou ay by dou x into dx. This is the that is the vectors formulas, the values of x direction and y directions, x direction and y direction. The maximum line integral of a vector over the rectangular path, that is a b c d, total value, so the maximum value is equal to then p plus q plus r, that is the p plus q plus r. This is then p and q is part is that is, these are p, so rectangular idea, that is a b, sorry, small a b c d. This is the rectangular, this is xyz direction, ax and ay direction, that is dx and dy. So the total maximum value of x and y along the direction. So what is the value of ax? So ax minus of dou ax by dou y into dy. This is dx. And again similarly bc side, the value of the value of q and plus the value of r plus the value of s, these are all adding that, then simplification of that value is simply then the rectangular of a b c d, so the value of ab and the value of bc and the value of cd and the value of da. So simplification then we get finally value is dou ay by dou x minus dou ax by dou y. So this is the xy direction. That is xy direction lo simplification is dou ay by dou x minus dou ax by dou y. Then similarly, this is component about the z axis. Okay, this component is z axis. So this is the unit vector is into k. So, and again, this is curl, this is z axis. This component is called the z axis term. This is the z axis is that is the unit vector is k. So curl az is equal to that is dou ay by dou x minus dou ax by dou y into k. Similarly, curl ay. So dou ax by dou z minus dou az by dou x into z term. And similarly, curl ax. So dou az by dou x dou y minus dou ay by dou z into I term. Okay, these are totally curl of a vector field. So curl a vector. So curl ax, curl ay, curl az, x-axis, y-axis, z-axis. These are both are adding this I term, z term, and k term. So this is the cross multiplication of the curl of a, that is I, j, k. Curl of a vector, that is I, j, k. You can prove that. That is dou a by dou x, dou by dou y, dou by dou z, that is ax, ay, az. Okay, this is the curl a. That is the proof of the curl a theorem. So first you can see first of all you can see PPT. This wait. Just wait. I can share the PPT slide. Sorry. So see, first we have observed that this is now I explain that this theorem. So let us consider that is the curl of a vector field theorem. This is curl of a vector field is means the line integral of a vector for unit area is called the curl of a vector field. That is denoted by sorry. Denoted by that is del cross f is equal to ijk, that is dou by dou x, dou by dou y, dou by dou z. This is ax, ay, az. This is det of. This is the theorem of curl of a vector field. This theorem is proof now. So see, first of all, observe that this is cross multiplication del cross a is equal to. So what is ijk? Dou by dou x, dou by dou y, dou by dou z. ax, ay, az. This is data. So this equation is observed that. So that is I term. I term is then close of I, then upper part and I term part. So that is cross multiplication. So dou az by dou y, dou az by dou y, that is dou az by dou y, and again dou ay by dou z. Okay, this is the I term. So next again, then close j term. This is close z term. This is also cross multiplication x term and z term. See, 1 minute. This is I, j, k. Dou by dou x, dou by dou y, dou by dou z. So ax, ay, and az. So that is cross multiplication. I cross. I term cross is that is cross multiplication in is I term. And again z term. Z term is also z is close. Z term is close. Then x az and ax az. So dou az by dou x. Like again dou ax by dou z. This is the z term. And again k term is close. Then x term, y term is cross multiplication. So then let us simplify k into dou ay by, that is dou ay by dou x minus dou ax by dou z. This is the cross multiplication. Then simplification is this equation. Okay, so this theorem is proof now. So what is, let us consider one rectangular form. That is rectangular is a b c d. This is the vector field which sides of that is dx and dy. And let us consider one midpoint is p, q, r, and s. So a, b, and that is a and a is let us consider a is the vector field. Inside the vector field is resolve these two components, x axis and y direction, x direction and y direction. So ax along the x direction, ay along the y direction. So that is the value of ax, that is midpoint of p. So ax, and similarly ax at a point r, that is upper part, and similarly at a point s, that is ay point, and q point, sides p and q and s points. So s point is negative and q point is positive. This is opposite direction, that is negative point. This term x that is so that is ax point at a point p, that is ax minus, that is midpoint but off. then of dou ax by dou y into dy. That is BC side, that is dy. Okay, similarly, these are P, Q, R as midpoints of this value of x-axis and y-axis directions. These are all adding. So that is the maximum line integral vector over a rectangular of A, B, C, D, A. So AX at a point AB direction and AB side and BC side and CD side and DA side. These are all adding that simplification, that is the ax ay ax dx ay dy, these terms all are all cancelled. This is the simplification. That is this is the simplification, that is the value of then this is dou ay by dou x minus dou ax by dou y into dx dy. This is the simplification, that is half ఉంటుంది, then two terms, 2 dou ax by dou y dx dy and 2 dou ay by dou x into dx dy. So 2 is cancelled, then simplification is the dou ay by dou x minus dou ax by dou y into dx dy. So this is the maximum line integral of the vector for unit area in ax direction, y directions. So by that is dx dy. Dx dy is cancelled, then this term is the z axis term. This components about the z axis term. So similarly, so z component that is z axis term, but that is the component of k, that is unit vector is k. So similarly, you can find the ax and ay. So I term and j terms, these are all adding. Then this is the proof of del cross A. So this is the cross multiplication of det. So simplification, this value same. So this is equal to this one is equal to, that is del cross A is means I is a k dou by dou x dou by dou y dou by dou z, that is ax ay az. This is the simplification of this theorem. Okay, so det of this is cross multiplication, then applying this value is a cross multiplication, this value. So this is the vector curl of a vector field, that is the theorem is proved. So same as it is divergent of a vector field, that is del dot f is equal to, then gradient of a scalar field, that is also del dot del f is equal to. These are all theorems are of that is the very important theorem is curl of a vector field. So curl of a vector field. What is the curl of a vector field physical significance is the divergence of a vector field, curl of a vector field. This theorem is, what is the physical quantities? Physical quantities is like the maximum line integral of a vector for unit area is called as the curl of a vector field. That is denoted by curl of a vector is del cross f or a. So now we could let us consider a and a vector del cross f. So what is the del cross a is equal to I j k dou by dou x dou by dou y dou by dou z ax a by az. That is the det of curl of a is equal to, we can find out. So curl of a vectors, and so these are curl means relation of vector and curl. So curl A is equal to, that is curl of a vector is equal to 0. The rotation is attack the vector in a vector field. Curl A equal to 0, that is called, this vector is called irrotational vector. Curl A or del cross A that is equal to 0, this vector is called the irrotational vector. And another one, the curl vector is not equal to 0, then some rotation is attached with the vector A. So that is the vector field is the curl A is not equal 0. That is the rotational vector. So curl A equal to 0 or del cross A, anyone. Curl A equal to 0, this is the irrotational vector, and curl A is not equal to 0, that is the rotational vector. Some rotation is attached with the vector A in the vector field. These are physical quantities of curl of a vector field. Okay, this is very important question. This is the curl of a vector. So okay, this is the curl of a vector field. Okay. Okay, any doubts you can ask her. Any doubts? So this is the vector and vector field, scalar field, and what is the then types of vectors, null vector, unit vector, product, that is opposite vector, and these are the types of vectors. And same again, what is the divergent, curl, and gradient. So that is the theorem of curl of a vector field. So del cross f is equal to Ijk dou by dou x, dou by dou y, dou by dou z, then ax, ay, az. That is the theorem is proof. So then any doubts you can ask. So